this demo, we are going to look at some of the basic challenges, why actually Hadoop really getting so popularized recently. To date, we will be looking at what is the current situation we are, what are the challenges we are facing. So as part of it, we will be looking at evolution of the business analytics and then even of the data processing and what are current systems, what are the traditional systems currently we are using. What are the basic company data volumes, like the basic challenge currently we have is we have a huge data collected as of today, but how much really we are using for our company decision making purposes. So that's one of the very important topics we will discuss. And the architecture of traditional RDBMS. So we have so many RDBMS systems, like Oracle, Teradata, and there are so many. Actually, we have one slide which actually explains the function of the traditional RDBMS systems as well. And we will basically go into what is Hadoop. So these are challenges we will discuss, and we'll discuss about what is Hadoop and how Hadoop can help us in this area, and where Hadoop we use. It's not Hadoop can replace all the traditional systems existing today. It's not, that is not the aim of Hadoop. And we will just look into that Hadoop architecture as well. And we are going to look at the Hadoop use cases, where best we can use the Hadoop. So these are the points we are going to discuss as part of this demo. And I will not go too much into technicalities of Hadoop and how it is stored and where it is stored, what are the properties, all those things, the comments and other stuff, because not none of you are like technical people. So I will I will just touch on the very important part of this Hadoop topic, but not the technical side of it. Much technical, but I'll try to give you a perspective about technicalities as well. So this is the analytics evolution. So from the day one, we started from. Please go on mute, please. I think there is some echo from background. So if you can go on mute, then it will be good. Unless there is, if you have any question or if you want to talk. So analytics evolution. So how we started with the ED mainframes and enterprise data warehouses. Then slowly enter into proprietary softwares like massively parallel processing systems like data and the other Netija, all those things are called basically like massively parallel processing systems. Then Unix-based systems we came into, and really parallel processing appliances, basically like appliances, basically like different required for analytics purpose. Then the stage we are entering into Hadoop. There's still a question mark. The market is still analyzing the Hadoop. Every company is still at the P level as of now. Analytics, what currently we have. Typically, the whole analytics area, the report area started with a small query in the beginning. Then we slowly it's evolved to the online analytical processing systems, the reporting systems, and the enterprise information systems with housing concepts. Paradigm is shifting to predictive modeling. How can we predict the behavior of the customer? By knowing all the attributes have collected from the long time to today, you can do something more to predict the customer. For example, if the customer else and his behavior, you see whatever the advertisement we are getting is not just like that sending. It's becoming from the predictive modeling or predictive analysis the companies are doing with the existing data. So they will predict, okay, next hour actually you go and buy some things. You not only even buying certain things, even if you are searching certain things in website, they will continue to keep track of the customer and your information. They will show the additional information where they can motivate you to buy the thing. So the predictive modeling is one of the very important areas which is growing right now. For the clustering segmentation, basically clustering segmentation is already used much in the financial sector when you go to banks and all, how they decide whether you need to get the loan or not is basically based on the cluster and segmentation algorithms. Typically, here the complexity is the parameter is shifting. It's not reporting. It's that you just look at the report, my balances, the what my day-to-day activities. It's based for future. On today's activities, predicting future is the paradigm shift now going on. So that's just basically how we can implement this. How kind of data I need to collect and where can I store, and the optimum storage or optimum processing capacity I can have. So these are basic questions now the companies are really facing. And if you really look at the Google and if you really look at the Facebook, collect at least minimum of 25 terabytes, minimum 20 to 50 bytes of data, and they have to process the whole data. So very big challenge for them. So this is one of the just about the big data. Challenge. So seeing the evolution of analytics growing one side, for that evolution, for coping with the evolution of this analytics, the data is another challenge. So I have collected so much of data. If you really Google it, you that 92% of the data is just collected last 2 years. So very really interesting topic, basically, like where we are collecting, how we are collecting. But typically, the whole data as of today we have is collected just 2 years ago. So very important challenge if you look at a company. Generally, they collect the data, whether it is archival or whether it's the tapes they keep, whatever data they keep, but complete they have around 2 petabytes of data. They have an average company. Again, it is not that it's a growing one side. At the same time, the minimum they currently have as of today at least 2,000 petabytes of data. Again, what is petabyte? I'll just give you a additional slide here. So a petabyte is nothing but like 24 terabytes. Terabyte is nothing but 1024 petabytes. So if you go to data level, there will be like 1024 exabytes. So it's data they are collecting. They have collected as of now. At the same time, if you really look at the side, among 2 petabytes of data, only 34 petabytes of data is available for users. Within only 4 petabytes of data is on IBM systems. So just 4 petabytes of data, if you really think, only 2% of data is available for analysis purpose as of today. Of data. So if the company wanted to really use more data for analysis purpose or more data for decision making systems, they have to put a lot of money, lot of for softwares like Teradata, Netija, or whatever it is you call, and that's going to be the huge expenses for the company. Another challenge we have seen. As of today, what are the products available and what is the evolution? So if you see the first traditional RDBMS systems as of today, we have examples are like Oracle, IBM, and DB2 SQL Server. So very has its own limitation. From that limitation, we have come up with a different architectures and different algorithms. Actually, if you see RDBMS structure, I can have is having a limitation of max 10 terabytes. It cannot really sustain more than a couple more terabytes. Like if really 10 terabytes of data, your system will hang any time. So get ready for that. So to avoid that kind of issues, the next level is COM-oriented databases. Tools are like Vertica, Greenplum, and IQ, CyberQ. They are capable of holding like hundreds of terabytes of data, but if it goes beyond, you will have that kind of limitation. Massively parallel processing systems like Teradata and Netezza also can hold up to petabytes of data, at least a certain 1 or 2 petabytes of data. But if the data goes beyond, then it also cannot sustain. So the next level, what we have is the big data. So we have currently the products is the product, and GoDB is also one of the product under big data. It's on top of Hadoop, typically it's a data structure, HBase. I think we will discuss that later. But this big data can have at least bytes of data. Couple of bytes of data it can hold and can process as well. It's not that it is able to store, but you need to process the data for that purpose. So here SQL is where it's not NoSQL. It won't work for SQL, but it's still not only SQL. So these big data depend for structured or non-structured data. At the same time, use SQL on top of it, or if you want to, you can use the file system processing as well. So that is the beauty of big data or Hadoop products. If you can, go and ask questions.
I'm good.
Yeah. Who is this? Anyone? Just on the big data with respect to analytics.
This is Surya.
Yeah.
Can I ask you a question?
Sure.
This NoSQL, the latest version of the database. When did this come into the market, or when did this start? The evolution of this new system. Just curious,
We will discuss that one once we come to Hadoop. But typically, the Hadoop architecture or algorithm is started by Google in 2004. And Google started with the column-based data, the implementation, what is it called, big column or big data kind of information. But that's where it actually started, 2004. Google and Yahoo and Facebook, these guys actually came up and they implemented that algorithm or architecture. Now it is Yahoo is successfully implemented, and they have now 4,000 nodes in the cluster. The initiation, it is started in 2004. So this much time to get into market and to popularize state. Okay. This is the traditional RDBMS system. So, how is RDBMS system even you take massively parallel systems, all these things, how really work? It's a simple. To you to the feeling of a table means to keep the data storage in a way of columns and rows. To get kind of picture, it has a lot of processing behind it. is it has to create so many logical entities on top of the file. Level of expenses, like you generally company will have a productionized system, and then there'll be a standby system. So you have to pay for standby systems and production systems. Both you have to pay. So in this way, you really go for this proprietary software. There is a huge expenses for the company. That's the reason, even though they keep 2,000 petabytes of data, but cannot really process the whole data for their decision-making purpose. The challenge we have. This particular slide is the logical level. It's a typical architecture. Even Oracle also processes on top of the file. It's a file again, end of the day. But it is slices and dices into different logical entities to show in the form of a table. So in case of RDBMS, this is what actually look like. The table is like a rows and columns. And of the RDBMS of today, they can hold only structured data. For example, employee data. Employee data, you will have employee ID, employee name, job ID, salary, all those information. It is clearly structured. But have any kind of unstructured data, there is no way I can create any kind of unstructured table in RDBMS. So this is a limitation in RDBMS, current RDBMS systems. But with Hadoop, you get any kind of data. So look at the data growth as of today. So you see, by 2000, every year the data we are processing is 40% more, 4% more than from last year. So that is 40% increasing every year. So by 2020 we will have around 45 zettabytes of data. This is just an estimation. It might be more as well if you really go level of growth. So this is a challenge. You are collecting so much of data. You don't know where to store it. You don't know how to process it. The main is limitations of current systems. Some cannot hold unstructured data. Some can hold only the structured data. And even then, if it can hold, but it's huge expenses. If you really want to buy Oracle system, you have to pay for your operating system. You have to pay for Oracle product. You have to pay for all other on top of it, security and any analytics products they are providing. So you pay each component of it. So basic challenges we have today. To overcome these challenges, again, as I was explaining, like we came up with a Hadoop architecture. The companies like the people, they have lot volumes of data. They started implementing this architecture, and they were successful in this year right now. They open source product. Again, the best thing here is it's just open source. You go grab it and implementing, starting the clusters. So that's the beauty of this whole system, whole ecosystem. Of course, you really wanted enterprise level, they do have different options. But even though the enterprise level as product, but comparatively, if you look at the other products, it is very cheap. So Hadoop typically now. So now we're slowly entering into the Hadoop. We have seen the challenges, we have seen the data growth, we have the different products available in the market and their relations of the Hadoop. So definition, Hadoop is a data storage and processing system, nothing than that. Open source, fault tolerant and distributed. It works on a structured environment, and number of nodes, performance will continue to grow. If you look at the Oracle system, right, you have a rack. If you a certain level of adding nodes, the performance typically goes down. It's not fully scalable there. But in Hadoop, the performance is like, as you add the number of node cluster, it will continue to grow. So that is the beauty of the system. It is able to store structured and unstructured data. So that is another beauty of the system. Basically, like most of the RDBMS, most traditional systems cannot hold that unstructured data. Like for example, I have emails. I mean, like I want to store somewhere. I cannot really use the RDBMS at all. This kind of limitation we have. And it was unreliable and handles hardware and software failures automatically. So if you look at the Hadoop architecture and the components, it has replication mechanism by its own. By default, the open source itself comes with a different replication algorithm. So if you put a file, it braces, and every piece of the file will be stored in different places. So different copies. Okay, so that means it has, by default, comes with a replication mechanism. So if one copy is lost, another 2 copies will be there always. And it maintains what copy is lost and what copy it has to keep updated with the copy. So these are the basic technical features of Hadoop anyways, but it has its own some failures, handling the system fails automatically. And the best advantage of Hadoop is you can just bring some kind of bunch of disks and attach it to this. That's it. You don't need to really go for huge Access boxes or huge Solaris boxes, IBM boxes, or any kind of huge software. If you have a good big computer, go ahead and attach it. That's it. So that's the beauty of the whole ecosystem here. So why Hadoop? Is the same challenges we have seen before, so which at least can solve some of them. Hadoop some of them, so people are Hadoop in the case. Another example why people are really going to Hadoop. We look at the traditional based storage system. This is typically the point of storage. If you look at the storage of other systems and compare with Hadoop, you really see the difference is at most like 100%. Like if you see storage requirement on sandboxes like 72,000, but if with Hadoop, you can do the same value, same quality with just $10,000. So see a difference you on the expenses side. The same if you see the per G storage weight, all other systems are like minimum 150 to 198 per dollar per GB, but with Hadoop you can get the just 30 cents to 50 cents. Seriously, the cheap, you can use the system at the same level of quality, same level of scalability. So the reason people are really trying to implement Hadoop in the technology. So cluster and going in depth of what is name node and job tracker and the secondary node, but it has own components to achieve this, whatever we were discussing, the advantages. It has like a particular cluster is a 6 node cluster with the 3 as a slave nodes and the 3 nodes as a master and master nodes kind of thing. These are in the Hadoop components, cluster components. Hadoop, so they are trying to go for at least 10 nodes. Already now, I think 4,000, 4,000, 5,000 Yahoo has. So they are trying to achieve minimum up to 10,000 nodes, 10 petabyte size. And the whole Hadoop is evolving. Typically, we can see that one side the open source software is evolving, the other side people usage is also evolving. The architectural view of Hadoop, the main component in Hadoop is the HDFS. Basically, it is a storage mechanism or architecture mechanism or algorithm. So as we seen before, it has the nodes and the node and slave nodes. Waste nodes are basically for data storage and processing, and master node will take care of the data dictionary information kind of thing. And the component of Hadoop is MapReduce. So MapReduce is for processing your data. So EFS is one component to store the data, and MapReduce another. Because I'm giving these words are like suddenly when people say Hadoop, they will talk about MapReduce. So that way you will have some idea about what is MapReduce. So MapReduce is to process the data. How it process? Typically process the splitting and the combine and the reducing mechanisms within itself. So the terabytes of file you can process. Advantage of MapReduce. Self-explanatory slide here, and it's Hadoop and with commercial RDBMS systems. So optimizers, most of the RDBMS will say optimizers like how it runs the SQL and what is the best ways to populate the data. And in case of Hadoop, you do all those things and run. It's basically MapReduce algorithm which retrieves the data for you. Running access methods, in case Oracle or Teradata, you use indexes or different types of indexes. But here the sequential scanning of file. You can use in HDF Hadoop, you can use any type of structured, unstructured, or semi-structured file. In case of commercial RDBMS systems, you have only structured data you can store. Of Hadoop, there is my here. You can just store any type of information in Hadoop. In case of traditional RDBMS systems, you have to have a schema or your database, whatever you call according to their terminology. But to have a structured design there. But here it is there is schema in Hadoop, and it's mostly optimization. Is optimization like you look at cluster and look at the memory, add nodes or remove nodes. In case of RDBMS systems, we have to keep separate team to do the activities. All things simple, structured, and ability to create complex data flows with Hadoop. So these are all challenges, additional advantages we have. So what currently we have with the traditional data flows. So we have the source systems, HR, human resources, or sales, or marketing data, financial data, whatever it is, and all this data will be processed according to the business rules, and the data will be pumped into the typical enterprise data warehouse. From there, we do the reporting or analytics purpose, whatever it is basically EDW is our main goal. But if you Hadoop, what will happen? So traditional systems will still the same. Basically, still need to continue the same marketing and HR and financial systems. But batch processing, most of the people are using Hadoop batch processing. Like you are processing the whole data coming from the source systems, and it will go to the parallel processing RDBMS systems for analysis. purpose. You can use them. Currently, there are quite a lot of tools coming up to read the data directly from Hadoop. Slide which gives all the product names as well. So cycle, I'll not touch much about that. This is again a simple cycle of the analytics area. It's again our SDLC kind of stuff. This particular slide will give you the different products available, traditional and with the Hadoop systems. So you for ETL purpose, we have currently in the as part of traditional systems we have Informatica, Data Stage, Oracle, House Builder, Teradata Warehouse Builder. There are so many ETLs. Every product has its own ETL. In case of EDW, we have database, Oracle, Teradata, SQL Server, DB2, any you can implement. Currently we use business objects or SAS or Oracle Business Intelligence, Enterprise Edition. So these are all our analytics purpose or business intelligence purpose. We use these products for any kind of reporting and analysis purpose. But it's a Hadoop ecosystem. So we have a quite additional. Again, all these products are open source products. For ETL purpose, they call it as Pig and Scoop. It's used to get data from source system and put it in Hadoop environment. So we have products for ETL purpose, and we have new products for analytics purpose. Typically, if you see the data meter, Karma Sphere, and MicroStrategy, so the different new products came up, the data directly from Hadoop for analytics purpose as well. Every product is coming up with a component to add directly data from Hadoop. So that is actually the future growth, future change. So the future value of big data. Again, this is collected from the McKinsey Global Institute analysis. So the predictions by using big data. So each sector has its own advantages. Just I will show it 1 minute. So healthcare is one of the beneficiary, and public. Every sector typically it's basically data. So if you look at the base difference here is instead of processing 2% data, let's process at least 20%. Do that. If I really go to process 20%, I need to have 4,000 RDBMS systems. Can I really can I have the capability to get 4,000 RDBMS systems? I can't. So alternative. So this is the solution for that. And another future of big data, it's really a sector wise. So the future with respect to the employment, I mean, typically they are predicting at least there'll be a gap of 50 to 60% people in big data area, either data analyst or data, whatever you call, because every role, what we have is typically exists for even big data. But to the data, understand the data, and to come up with design how we can use this particular data. So we quite a lot of people to activity as a data analyst as well. Cartoon just for fun. If I'm going speed or something, they're all technical, so I can just.
The pace is good, Rajesh, and I'm very technical myself. So
that's fine. Thank you. Used cases. So as I was telling you, is it to 12%, 22%. So where I can use this big data. or big data products or big data concepts. In fact, everything is like, everything is new now. If you see Staples used to send like, big books, this much big books. You can resend it to the right customer. They may earn more than send it to me, where I'm even going to Staples, right? So basic difference now everybody is looking at. The risk modeling. Now see, every financial sector has started a separate department of risk modeling. A bank. They see the news of JP Morgan. They are paying around $900 million to the government. It's some kind of, I cannot say it's a fraud or something, but it's just because they are paying because there is some mistake happened in the trading sector last year. Paying, I mean, SEC has come up with, this kind of deal. So how can we get that? So spend money and get better systems than paying in this way. Modeling and okay, companies really lose customers. If you have already you have the data, if you can really process the data, you can really analyze the customer, keep the customer. So if you see more customers go from AT&T to Verizon to AT&T, what reasons? Either way you can keep up the customer. So that way, basically it's a predictive modeling. Again, these things are nothing but a predictive modeling. Can we predict customer preferences? Why not? You have data. If you need to process it. So this area where you can use data or data products. The biggest advantage is cheaper. And again, the whole Hadoop concept is depending on only one single point. This is cheaper. And basically the whole thing depends. And we can use is in our targeting. The companies can increase the campaign efficiency. And point of sale transaction analysis. So you can retail target promotion guaranteed to you by so that they can send the right advertisement to the right people instead of sending to the wrong people and lose money. Advantage is area of usage cases, used cases, network data to predict failures. Typically, you can use as a mechanism or as by using your failure point of network. You can predict when the network go down or when it can you can take some precautionary measures on the networks. And the analysis. This is one of the areas where everyone has come across. Like how can any credit card company can immediately call you if there is a wrong transaction or a abnormal transaction happens. Basically, there's nothing but a particular runs. If you are rerunning effectively, you can catch more cases like this, or you can prevent these cases. And this trade surveillance, which we were discussing before about JP Morgan. You can always your searches will be better. You have a large amount of data sandbox. Basically, new data. How can I store it? So this is a fundamental storage mechanism of the data. So for fun, what goes typically of the day, it is implemented this way. Okay. So this is true most of the cases. All right. So it's about the group. So if I'm just opening up for the questions, if you have any question, you can go ahead and ask. Anything under the sky, just make it as an open discussion, and if you have any type of questions.
Just a quick question. What does
Right.
mean node? What is a node? I don't have technical knowledge regarding IT or anything. I just want to know
Okay.
what is a node.
Node is just a computer. Okay. With a processing capacity, with a storage of you can keep 1 terabyte or terabyte, whatever it is the storage, which is minimum 8 GB of memory, so that you can just add to the cluster, which as a node, using it for storage purpose, and for MapReduce will use it for analyzing the population purpose. It is nothing but a small computer.
Rajesh, you had a slide about the number of cores for Hadoop versus other traditional RDBMS and all that. So, but I'm just wondering if you add cores, all these 50 plus cores, as opposed to one or two, well, wouldn't that cost money? So shouldn't the expense be high for such ecosystem compared with RDBMS? So I
This
think
one I meant.
the one for that there was two slides side by side. Previous one, yeah, it one. No, no, I think we just passed
Let me go slow.
this one. On the table on the left shows how cluster has up to 50 servers and cores up to 684. So the hardware cost, when you consider, I'm just wondering why is it cheaper when in a Hadoop environment compared with like traditional storage?
Traditional storage, typically the traditional storage has proprietary software, right? They charge you based on whatever a product. Let us take for example Oracle. How they do per user license, right? If you are going to buy a system, IBM, AIX, or Sun Solaris, whatever it is. So if you come all these costs, whereas in Hadoop, really do not need to go that high level of system or hardware or software components. Okay, just to buy a small regular computer and you can attach it. But of course, it all depends on how corporate wanted to go, but has the capability of a normal computer, normal disk. You can just add it to the cluster, and it can use the processing power and the storage. It's not you do not need any proprietary kind of where you pay licenses and support. Here it's just a small computer you can attach it to the cluster.
Okay, thank you.
Rajesh, you mean to say, right? It's just this Hadoop is just like a storage device, right? Anyway, you need some kind of UI application to use, like Oracle or something, to retrieve data from this database, right? Hadoop.
Right. Mm-hmm. Typically, you are right. It is not the replacement of RDBMS.
I understand.
Okay, it's more the analytics area, the people where they process huge of data. For example, VW, right? Huge sets of data. Because today, RDBMS has 50 terabytes of data. Data they use for the processing, the analysis.
Right. So,
did you really? Okay, go ahead.
What is that?
So you really use those systems for the processing per se, because you have open source available,
Right.
processing, and get same details, and you can push it to RDBMS for analytics purpose.
Right.
Right. So,
Can other example is like in Oracle or RDBMS, right? We have data blob columns where probably there might be a limitation, but in Hadoop maybe there's no limitation. I don't know. Maybe I'm just putting away question. So just we can retrieve data. I mean, it can store like huge volume without any limitation on the blob kind of thing what we have currently, and then and we use the UI component to retrieve the data the way we need to format it and present it the way user wants it, right?
typically, you can have any of class or blob columns cannot exceed around, I think it's a 64 GB or something.
Right.
If you really have any kind of data which is more than that, very key.
I mean, how do we like store? I mean, this is structure-wise the way we Oracle use, or it should have kind of architect layout how to store the data in Hadoop database, right?
It's typically very simple. It's visualized as a file, right?
Oh.
You store the file. That's it.
I got it. So that makes sense.
Okay. Exactly. So file is the file. Let me show you another, ecosystem components, right? So each component has its own right. So you see this one, right? So FS is just a file. You visualize it's just a file. On top of it, HBase. So HBase will convert as a typical column-based database, and it will retrieve as a database, as a database query kind of stuff. Right. Map reduce. And it you have a pig, which is basically 80 years old, and it is basically like SQL kind of stuff. Okay.
Right. Basically, so Hadoop will store in a like kind of file format system.
Format, yeah. Most of your data, if you really end of the day look at, most of your sources are files.
Right.
On entry systems.
Right. Okay. So basically, we'll be looking at that particular node to retrieve the data and present it.
Right.
Okay.
Exactly.
And Rajesh, could you please advise us on what are the prerequisites for this course? In other words, what are the languages or something that you need to know to be a good user or get this tool? Like, what do you please advise us?
Well, this is a good question everybody asks, but typically the answer is simple, right? If interest, that's good enough. Everybody has to start somewhere, right? Born with Oracle known, but I am working for last 17 years, right? So start somewhere, that is different thing. But the prerequisite, if you already into this one, if you, for example, right, some people are is required for Hadoop. Pig, Hive, HBase, all these things you have very simple SQL format kind of array code. But if you know Java, then that is easy. You go ahead and write the map reduce jobs. And if you learn C++, you can write libraries on top of MapReduce and on top of HDFS. Anything you start SQL, Hive and Pig SQL, and custom administration. You got is it
yep.
Answers?
I got the answer. Thank you.
So one more example is like use SQL as the UI and then use this Hadoop as your RDBMS database, and then you can write your own query to retrieve data, right?
Yeah, I mean typically it's not straightforward though, but you can do that. Yes, I mean we have this Hive which can create its own MapReduce jobs to populate data like RDBMS systems, like SQL program.
Another example is
right. Again, even Hive, Peak, what they do is they create their own programs, their own MapReduce programs in Java, and retrieve the data for the SQL you have given.
I have this is Suraj again. I just quick question. So I mean,
Sure.
this big data is a term that is that's something new, and it's it's all over, like on the news, on the newspaper, and all that. And I'm just trying to understand this technology stand when compared with Amazon's, like web services and other big companies. They have their own languages and systems that they use for big data. I mean, how does it compare? How does this tool compare with other tools? And what is the future of this tool? I mean, that might be another question. If you please answer that. Thank you.
If you look at cheaper range processing capabilities, right? What is the corporate wanted right now? They are looking this kind of solutions. To say different people use different ways, yes, there are quite a lot of projects, quite a lot of languages, quite a lot of analytics areas. There are quite a lot of this is huge. We wanted to use different products in a different perspective. For example, online data entry processing. You not actually avoid the data systems there. And predict analysis. You take like terabytes of file, and you take any of our traditional RDBMS, not really process it. At the same time, you don't really need the data with 2 minutes or 3 minutes. You need the data for analysis purpose. Everybody knows it takes some time. It's not a real time. Basically, it's a file you are processing for future. I need immediately the retrieval of data. You are waiting for the data to do something, nothing like that. So, in this, Hadoop is used for that slow and batch processing systems. And there are additional components which you can even use for real-time data processing, like this and Hive. And of languages, I mean, you take for example a new language now. It's R is coming up. Like there are 200 to 300 customers are using R language, basically for revenue analytics by analytics side, like statistical analysis is done with language. Right? Languages, I mean, Java is simple, like everybody uses. It depends on mainly whatever you use. It depends on the people in a particular organization. They know that they start using it. It's not it is the best to use, but if there are people who knows that language, they start implementing that. That's the way it goes. Questions, please. Questions? So there are no questions. Okay, go ahead.
I was just wondering how the course. Please give some details about this course. How long it's going to last?
Actually, I forgot that slide to show you guys. I mean, like the course, right? Yeah, the contents of this one will be. Now reminding me that this course will contain warehousing concepts. Number two, Hadoop cluster build, Hadoop cluster maintenance, and two places. One is virtual missions, and most of the people will be asking on these two. Because two has they provide us the services to create your own clusters and and manage. In fact, EC2 provides include Hadoop software installed already. So the different ways in EC2. End of the day, you can create your own cluster. You can. We will be learning how to create, and we are learning about map reviews. Whatever the one first. Then MapReduce program. And then we will be learning about there are the different modules, but these are complete information about the Hadoop. Hive, we will be learning Hive, we will be learning Scoop, we will be learning Pig, and certification information, and a small reduction to our language as well. But again, so we will send you the contents of the course in different modules. Okay. Typically, this is the stack, right? We have seen this one before. So you will be learning on HDFS, HBase, MapReduce, Big Hive, Java. Yes, myself I'm not great in Java, so much. But I'll show you some examples on how to execute Java programs. Small examples. Every organization requirements are different, so these things go with the different ways there. Write the programs and execute them.
Okay.
So much, guys, and have a good night. Then.
Thank you.
Very nice.
Thanks.
Yeah, bye-bye.
Go ahead.